We're going to look at some practice problems to help us get ready for our first exam. For this first example, the directions say list the intercepts and algebraically test for symmetry. And for part A, the example is y squared is equal to x plus 9. So let's find the intercepts first. To find the x-intercept, you're going to let y be 0, and then you're going to solve it for x. So we're going to have 0 squared is equal to x plus 9. Solving this for x, we have negative 9 is equal to x. So then I get the ordered pair negative 9 comma 0. To find the y-intercepts, you're going to let x be 0. So you're going to have y squared is equal to 0 plus 9, or y squared is equal to 9. Solving this for y, we're going to take the square root of both sides. Don't forget about your plus or minus when you introduce the square root. So you're going to get y is equal to plus or minus 3, which gives us the ordered pairs 0, 3, and 0, negative 3. So all of these together give me my intercepts. Now let's do our tests for symmetry. So for x-axis symmetry, what we're going to do is we're going to replace the y with negative y. And we're going to see if we result in something that's equivalent to the original equation. So then I'll get y squared is equal to x plus 9. And yes, this is what I started with. So this equation right here will have x-axis symmetry. Now we still have to test for the other types. So for y-axis symmetry, we're going to replace x with negative x. So I get y squared is equal to negative x plus 9. And there's really not much to clean up on this. This is not equivalent to what I started with, so no, this one will not have y-axis symmetry. And then to test for origin symmetry, we're going to replace y with negative y and x with negative x and see if we result in something that's equivalent to what we started with. And we're going to see that the signs don't quite match up, so no, this one will not have origin symmetry. So let's take a look at our next example. So I'll repeat the equation down here. It's going to be y is equal to x squared minus 4 all over 2x. So let's test this for let's do the intercepts first. So to find the x-intercept, we're going to let y be 0. So I get 0 is equal to x squared minus 4 over 2x. Multiply both sides by 2x to clear that fraction. We're going to have 0 is equal to x squared minus 4. Now there's a couple different ways that you could solve this. I see that I can factor this into the difference of squares, so I'm going to go ahead and do that. And that's going to give me x is equal to 2 or x is equal to negative 2. So writing those as ordered pairs, I get 2, 0 or negative 2, 0. Alright, so let's go ahead and find the y-intercept. So then to go find the y-intercept, we are going to let x be 0. So I get y is equal to 0 squared minus 4 over 2 times 0. Now upstairs I get negative 4, but downstairs I get 0. Okay, so that's a problem because you can't have 0 in the denominator of a fraction. That's undefined. So this problem will not have any y-intercepts. It will only have these x-intercepts. Alright, so let's do our tests for symmetry. So for x-axis symmetry, we're going to replace y with negative y. And we're going to see if we result in an equivalent equation. And again, there's not much to clean up on this, and we can see that the signs are not going to match up to what we started with. For y-axis symmetry, we're going to replace x with negative x in the original equation. And cleaning this up, we're going to get y is equal to x squared minus 4 over negative 2x. And again, this does not match up to what I started with. I have this negative downstairs that I didn't have in the original problem. So nope, it will not have y-axis symmetry. So then finally for origin, we're going to replace y with negative y and x with negative x. And let's go ahead and start cleaning that up. So I'll get negative y over here. Up here I get x squared minus 4 over negative 2x. On this problem, if I multiply both sides by negative 1, I can get rid of those signs. So I get y is equal to x squared minus 4 over 2x. And that does match up to what I started with. So yes, this one will have origin symmetry. Alright, let's keep moving on. Alright, for our next example, I'm going to repeat it down here. So for part C, the equation was y is equal to the cube root of x. So first, let's take a look at our intercepts. So for our x-intercept, we're going to let y be 0. And solve this for x. So to undo cube rooting, I'm going to cube both sides. So we get 0 is equal to x. So this is going to be a solution. It's going to generate for me the ordered pair 0, 0. And for the y-intercept, you can see that this is also going to be a y-intercept because it has y being 0. But if you wanted to formally go through, if you didn't catch that, if you let x be 0, there's where you can see that you're getting it, y is also equal to 0, so there's your only intercept. Alright, let's do our test for symmetry. So for x-axis symmetry, we're going to let y be negative. And we're going to see if we get something that's equivalent to what we started with. So we get negative y is equal to the cube root of x, which, nope, that's not what I started with. For y-axis symmetry, we're going to let x be 0. I'm sorry, x be negative x. And we can pull that negative out in front of the radical, but I can still see that I don't get what I started with. So no, it's not going to have y-axis symmetry. Now for origin, we're going to replace y with negative y and x with negative x. And on this one, here's where we can see if we pull that negative out in front. And then again, I can multiply both sides by -1 to get rid of those negative signs on both sides. And I do get back my original equation. So yes, this one will have origin symmetry. Alright, so for our last example, so I'm hoping you're seeing each one of these equations kind of had some different element in there. So this last one is going to have an absolute value. So for part D, the equation was y is equal to the absolute value of x minus 2. Alright, so let's first look at our intercepts. Alright, so for x-intercept, we're going to let y be 0 and solve this for x. So I'm going to get 2 is equal to the absolute value of x. Now to solve this absolute value, we're going to break into two cases. Either x is equal to 2 or x is equal to -2. Right? So that's going to generate for me the ordered pairs 2, 0 and -2, 0. Remember to write your intercepts as ordered pairs. For the y-intercept, we're going to let x be 0. So if I substitute 0 in for x, I'm going to get y is equal to -2. So that's going to generate for me the ordered pair 0, -2. So then all of these are my intercepts. Test for symmetry. X-axis symmetry, we're going to let y be -y and see if we get something that is equivalent to what we started with. And I don't have the right sign on this, so no. It will not have x-axis symmetry. For y-axis symmetry, we are going to let x be replaced by -x. So because of the absolute value, I can clean up that sign. And on that one, yes, I do end up with what I started with. So this one will have y-axis symmetry. And then finally for origin, we're going to replace y with -y and x with -x. And if I go to clean up my signs, yeah, I still have this problem that I have this negative on this y. So that one will not have origin symmetry.